AWS Application Migration Service, or AWS MGN, is a lift and shift AWS service that can be accessed through the AWS Management Console. We will now review the AWS MGN service and network architecture. AWS MGN is a flexible, reliable, and highly automated lift and shift solution. You can use it to help simplify, expedite, and reduce the cost of migrating applications to AWS. Use AWS MGN to migrate physical, virtual, or cloud servers to AWS without compatibility issues, performance disruption, or long cutover windows. You can migrate applications and databases from any source infrastructure that runs supported operating systems. This includes common databases, such as Oracle and SQL Server, mission-critical applications such as SAP, and homegrown applications. AWS MGN supports most common Windows and Linux operating systems and continuously replicates their data at the block level. On the left side, we have the source environment, which can include a combination of physical, virtual, or cloud servers. In this example, the source environment has 2 servers, with 2 disks attached to the top server and 3 disks attached to the bottom server. On the right side, you see the AWS region where the servers will be migrated. In this example, the subnets have already been defined. First, install the AWS replication agent on your source servers. The agent can be installed in an unattended fashion and does not require a reboot. Upon installation, the agent performs an authentication handshake against the AWS MGN API endpoint, which is encrypted with TLS 1.3. This registers the agent with the service, which in turn automatically provisions the staging area subnet resources. The staging area subnet uses low-cost compute and storage to keep the data from the source environment in sync on AWS. The staging area subnet consists of the following resources: replication servers, which are lightweight Amazon Elastic Cloud Compute, or Amazon EC2, instances. Staging volumes, which are low-cost Amazon Elastic Block Store, or Amazon EBS, volumes. Amazon EBS snapshots, which are incremental EBS snapshots. For every source disk replicated, AWS MGN creates an identically sized EBS volume in the staging area subnet for data synchronization to occur. In this example, the 5 replicating source disks result in 5 equivalent EBS volumes attached to the staging area replication servers. After the agent is installed and the staging area subnet resources are created, replication begins. The data is encrypted and transferred directly from the source servers to the replication server volumes. The replication path is controlled by the user, and private connectivity options can be used, such as AWS Direct Connect or a VPN. The service automatically manages the staging area subnet resources, scaling resources up or down as needed based on concurrently replicating source servers and disks. Therefore, there are no maintenance operations required from the user to manage the staging area subnet. AWS MGN servers are ephemeral resources and are automatically rotated from time to time by the service. Important information to note. 1. Replication servers use T3. Small Linux instances by default, with T3 unlimited pricing enabled. 2. A general rule of thumb is that one replication server can handle up to 15 concurrently replicating disks, and 3. Data is compressed and encrypted in transit using an AES 256-bit encryption key by default. It can also be encrypted at rest in your AWS region using Amazon EBS encryption. Replication starts with an initial sync. During the initial sync, the agent replicates all of the content on the source disks to EBS volumes in the staging area subnet. In parallel, the agent tracks and continuously replicates data writes as they occur, and asynchronously replicates the data to the relevant resource in the staging area subnet. Continuous replication continues indefinitely after the initial sync is complete. After the agent is installed and replication is in progress, review the launch settings. The launch settings are a combination of service-specific configurations and an EC2 launch template. The launch settings define where and how migrated instances are launched, including subnet, security groups, instance type, volume type, and tags. After the launch settings are configured, wait for the initial sync to complete. When the source server is marked ready for testing, you can choose the Test and Cutover button and launch instances. AWS MGN will then issue a sequence of API calls to initiate the launch process and automatically launch the instance on AWS according to your configured launch settings. During the launch process, the service automatically spins up a conversion server. The conversion process includes changes to the drivers, network, and operating system license so that the instance boots natively on AWS. Unlike the replication servers, which are active as long as replication is active, the conversion server is spun up only for the specific purpose of converting servers during the launch process and is then immediately terminated. After the conversion is complete, the new instance is spun up on AWS and ready for use. Note that the volumes attached to the launched instance represent the source server state at the time of the launch. After the launch, the newly created volumes are no longer kept in sync with the source servers. Any changes made to your source servers are still continuously replicated by the AWS replication agent to the staging area volumes, but the changes are not applied to the launched instances. Every time you launch a new test or cutover instance, it will reflect the most recent state of the data replicated from the source server to the staging area subnet. With this design, you can quickly test spun-up instances without disrupting the source servers or replication process. You are also able to spin up the most up-to-date copy of source servers on demand. Launching a new instance for the same source server will automatically clean up and override a previous copy of that server if it was previously launched. This helps minimize costs and avoids accumulation of unused resources. To prepare your network for running AWS MGN, set the following connectivity. Number 1. Connectivity between the source servers and the AWS MGN API endpoints. Allow for connectivity on port 443 between the AWS replication agent on the source servers and the AWS MGN endpoint. This connectivity is used for authentication, configuration, and monitoring purposes. This connectivity must be in place for the AWS replication agent installation, and as long as the source server is replicating. This is an HTTPS connection and, as such, can be redirected through a web proxy using standard settings on the source server. You also need to allow connectivity between the source servers and S3. Set this connectivity so that the AWS replication agent can retrieve the necessary software components from an S3 bucket. Number 2. Connectivity between the source servers and the staging area subnet. The AWS replication agent sends data directly from the source servers to the replication servers on port 1500. Therefore, connectivity must be allowed over port 1500 for continuous data replication. Number 3. Connectivity out of the staging area. The AWS MGN replication servers and conversion servers, which are launched in the staging area subnet, must continuously communicate with the AWS MGN endpoints on port 443 for authentication, configuration, and monitoring purposes. This connectivity must be in place as long as replication is in progress. In addition, connectivity to S3 must be allowed. When the replication or conversion server is spun up, it connects to an S3 bucket to download software and configuration files. Finally, one of the roles of the replication server is to issue an API call to take snapshots of the staging EBS volumes during replication. To do so, connectivity to an EC2 API endpoint on port 443 must also be in place.